Our sun, the life-giving star at the center of our solar system, is dying. It was born 4.6 billion years ago, along with the Earth and our entire solar system. But like all stars, it will have its end, its final day, and that day is slowly approaching. It won't be for about 5 billion years, and it won't die quietly. It will be a dramatic and cosmic spectacle, billions of years in the making, but it will come. The sun is beginning the middle age part of its life, fusing hydrogen into helium in its core, a process that generates the light and heat the Earth and other planets rely on. Imagine this: our sun fuses 600 million tons of hydrogen per second, and its middle-aged stage will continue for another 5 billion years. That is an inconceivable amount of hydrogen, but eventually the sun will exhaust it all, which is when the big problems begin. As the hydrogen runs out, the core will contract under its own massive gravity, causing it to heat up. This increase in temperature will ignite hydrogen fusion in a shell surrounding the core, and the outer layers of the sun will begin to expand. Our sun will transform itself into a red giant, swelling to a size that engulfs the inner planets, including Mercury, Venus, and maybe even Earth. If the Earth escapes being swallowed, it will be scorched by the sun's intense heat as it balloons to hundreds of times its current size. The once golden sun will now be a bloated reddish beast in the sky, its gravity struggling to hold on to its outer layers as they drift away into space. During the red giant phase, the sun's core will become increasingly unstable as the temperature rises to 100 million degrees Celsius. This is when the core will begin fusing helium into carbon and oxygen. This brief phase of helium fusion will last for only a few 100 million years, but it will be a turbulent time. The sun's outer layers will pulse, and enormous amounts of mass will be thrown off into space, forming beautiful and glowing shells of gas, becoming what is known as a planetary nebula. At this point, if the Earth hasn't been swallowed, it has been completely scorched, turning it into a lifeless ball of rock. The oceans will have long boiled away, the atmosphere that gave us our brilliant blue skies, stripped away millions of years ago. Any remnant of life will be long gone. The Earth will be a sterile, molten planet, returning to what it was when it started its life 10 billion years ago. When the last of the helium in the sun's core has been fused to carbon and oxygen, the sun will no longer have the energy to resist gravitational collapse. The core will shrink down to a dense, hot ball of carbon and oxygen, as it is no longer capable of fusion. What is left is called a white dwarf, an incredibly dense object roughly the size of Earth, but with nearly the mass of the sun. The outer layers of the sun will have blown away, leaving a hot, slowly cooling core. But it's still not over for our sun. It will remain a white dwarf for an astounding 1 trillion years. But it will slowly fade, growing colder and dimmer over billions of years. It will eventually become what is called a black dwarf, a cold and dark remnant of what was our brightly glowing, life-giving yellow star. By then, the sun's light will have long vanished, leaving our solar system cold and dark, a far cry from the warm and vibrant star it once was. No black dwarf stars have been discovered, because our universe is only 13.8 billion years old, but it's a certainty that our sun will become this last and final iteration of what it once was, a black dwarf. After a reign of more than 10 billion years, the sun will meet an inevitable death, leaving behind a glowing nebula and a small, dense blackened core, a lasting monument to the violent and beautiful life of our star. We thank you for watching, and we'll see you in our next episode.